Alright, dudes and dudettes. Let's continue this absolute cavalcade of live streams. At no point in the history of the human race has anyone seen this amount of live streams. It's absolutely bonkers. Do you remember that on one of your streams I said I wrote a tag-based file concatenation? Yes, I do. I do. It was sometime during the 8th of November. Yeah. Sometime during the height of pre-alpha 1 crunch. Or maybe the beginning of it. Yes, I remember. I don't know exactly what that means. I mean, I have some theories what that might mean, but I don't know exactly what that means. Feel free to enlighten me. In the meantime, welcome everyone. If you were just here about an hour ago, you know what we're doing. We're building the truck. We're building the gripper truck. We're building not that, but this thing. We're building out this thing. Yeah, I just had a bit of a break. Went to show my face to my family, and they said, "All right, that's enough of that. Go back and stream some more." So here I am again, and we're gonna continue building out this thing. There's something seriously wrong with this vehicle, though. Why is it driving so ridiculously slowly? I'm gonna have to have a look on what is what is causing this guy to like not like turning and accelerating at the same time. And let's do that right now by disabling some of these. Let's see. And server, let's take those away. We can have a mesh there, that shouldn't impact anything. And then we'll take those away. So now I disabled both the bed component and the gripper arm component. And so now nothing should work, and indeed it doesn't. It's still pretty. Oh, there's actually okay, yeah. I think I know what the problem is. Is that damn differential issue once again. It's just that you can't seriously see what these wheels are doing here. Yeah, like now we can see that this wheel is rotating here with this visualization on, but you can't really see it if you turn it off. Well, maybe you can. Oh, sorry, didn't watch this, the chat. It opens two text files and looks for a specific string in one, then if it finds it, it will copy the other thing, find its location. Pretty basic stuff in C. Now I'm much better at programming. Well, that is how you do it. You just do it. Thanks to all streams who make lonely hours of programming more bearable, like yourself. Yeah, solo indie dev is very solo, right? Yeah, I have no idea what's happening with this. Right, now it's that wheel. Okay. I'm wondering if there's like... Actually, let's turn the game back on. And let's see. Creeper truck. So it's very sort of susceptible to getting stuck right now. And yeah, now clearly everything goes to this wheel that's like closest to us. Okay. What if we adjust the spring strength down quite a bit? And that doesn't seem to do much. All right. Yeah, now it's that wheel. Is it really possible that this doesn't work without the torque vectoring? Seems a bit weird. That would be the case. Yeah, the wheels are sort of lifting. I mean, in some sense that makes sense. If the spring strength is so ridiculously large that essentially the whole vehicle can stand on one wheel, then that would cause this to happen, because that would cause these wheels to just like stand in the air. Spring strength. Kind of feel like it doesn't really matter though. That's surprising. What? What is happening? Put some cargo in the back here. And actually we don't have this bed here now, so it will fall through it. Like that. Oh, that will actually fall off it. There we have a little bit of cargo in the back. Right, so now you can see that it is it's pressing down, but like why is like what? What? It's confusing. So yeah, now that we have this standing, now we have those two wheels in the air, and that's not good. That is not good. So this is clearly like too strong. But I just feel like it shouldn't have this much trouble actually getting going. I know this is not really what we were supposed to do, but of course if you can't really drive with a vehicle, that's a big problem. So it makes sense to investigate this a little bit. there's clearly something that has changed. Let's do a diff on this guy. Yeah, so it's just the spring strength stuff. Okay. Let's do a history on it. History, show log. Off to the side. Right. Because one thing that I did was I moved the center of mass a bit forward. That might, of course, cause a little bit of issue, because we can see that the left front wheel and the right front wheel, they're not driven. Driven false. Right? And then the rear wheels and the middle wheels, they are driven. Right. So that might be one thing. Let's actually make these driven as well. That will probably make it a bit better, but not a whole lot. It's very sort of sluggish, at least in the beginning. Yeah, I wonder if we... what wheel mesh do we use for this? Materials, truck 2 wheel block out. Okay. So what I think we're gonna do now is I'm gonna make a wheel for this in Blender. So here's wheels. Let's just take one of these and duplicate it and separate it. Yep. Separation. Let's move the cursor there. Set origin to there. And we don't want to. Oh no. Just for that. Thank you very much. Remove the mirror. And we'll do now we do set origin 3D cursor. And then we can move this to the center, right there. And the reason I want to do this is because I want to add something to this wheel so that we can see if it's actually rotating. So let's do that. Let's just make it so that it's not so difficult to see what is actually happening. Something like that, and then we do. Where are my tools? There are my tools. Extrude along normals. Just outside a little bit. Something like that, and then I think basically we want basically these. There might be an easier way to do this, but I don't know. I don't know, and I don't want to necessarily figure that out right now. And this is not going to be the final wheel for this truck, most likely, but just something that we can play around with right now. So individual origins is good. Scale. Alright. That should at least give us an idea of what is happening here. Let's call that just wheel. And save gripper truck wheel. Oh, and probably need to do that one as well. All right. What about that? Now we should be able to just get that there and take render mesh is there. Let's launch the game again. There we have wonderful wheels. and now it looks, I can actually see them rotate, and you can see some of them kind of not really almost doing anything. Alright, this is strange. Hey Alex, welcome back. Yeah, now you get this funky looking phenomenon where it looks like wheels are actually rotating backwards and all of that. Very curious. Very curious. So what I'm gonna do now is this. I'm going to download a build from my build server. Let's see. From what is it? 7 days ago. That should be good. Let's put it on the desktop. And I'm gonna compare this card to that, because I feel like we have some issue here which hasn't been around. And it's probably something that I've done to this vehicle, which kind of makes it super sluggish. It might just also be that I just haven't played with this car enough to see it. But it definitely feels too sluggish for this. Actually, we can do another thing. There's an older version, which this thing is actually based on. It's this truck number 2. How sluggish is this? It's not very sluggish at all. Kind of just gets going immediately. Right? Kind of just gets going. It's like a prototype truck. So if we, if we put it here, sort of like similarly to how we spawned that thing, there's like, yeah, there's a little bit of sluggishness, but not at all as much as with the actual thing. So that's strange. It's very strange. Right, so what we can do is we will do diff between truck number 2 and gripper truck. Let's see what that gives us. So, yeah, we have some offsets here that are kind of not necessarily a problem. Spring strength is here set to 30,000, so that is definitely higher than what we have here. The gripper currently. Radius is 0.578. Is that actually the same as we have here? 0.578, and with the gripper, oh, what? That's probably it. 0.578. Yeah, that should be that. I'm gonna bring the spring strength over. That would most likely cause that sluggishness to happen. Sluggishness. So gripper truck. No, that didn't help. Yeah, because this thing has like big problems just like backing off. Okay, that's not it then. But that is definitely a problem. If these shapes here are 0.578, then they need to be 0.578 the vehicle definition as well. It's a little stupid that you have to give them twice. That can't be helped. We have chassis center of mass is 0. Yeah. All right. We could even put this on the vehicles, make them even more visible. What about this then? Center of mass. Let's move that over as well. Save that. Let's see what we have in game. Oh, actually not this. No. Yeah, now we have like the checkerboard texture there on the vehicle. Right, so yeah, I think that was it. I think it was that. Yeah, look at this. Now we're just speeding like an absolute champ. Yeah, now it has no issue doing anything. I think it was the center of mass thing. That was the issue. Now this is like the speediest of them all. Bonk. And we're stuck. Bloop. Yeah, I think the center of mass thing was the big issue. I don't know why I keep shutting this down, because this is one of those things that is just super hot updatable. Right, so now we try to just back away from here, nothing happens, can't do anything, and then we set this to 0.0. Look at that, now it just works. Okay, so that was a problem. That was the issue, and I'm gonna do this again. Yeah, let's reload. So basically we want that material there, like so. And now let's see. Engine max rotation speed I think is pretty good what it has been. Steer rate and fall rate, that just means how quickly do the wheels actually steer. They're sort of slow here, and I think that kind of fits a truck pretty nicely. So do we want this to be all-wheel drive? I do think we want that, yes. Top speed 80 is probably good. Orbit camera distance 15. Yeah, the rest of this is good. Cool, so now we can, sure. Now we can re-enable those components of ours. So now we actually do have to start the game again. So we're looking for this guy. That guy, gripper, truck arm, and truck bed. There we go. let's see. Yay. Let's see how well does it actually drive now with that hitting the ground. Yeah, that is an issue, but that is an issue that I kind of want there to be. I want to be there, because it is clearly like more realistic that this is the case. If you want to pick up something really small, you just ram that thing into the ground, and then once you've picked it up, you raise it a little bit, and then off you go. And now we have no problem whatsoever driving this thing. And yeah, all-wheel drive makes sense. I don't know why I had that turned off. That was gonna be probably a stupid thing to have. Cool. Okay. Much nicer. I don't know if it comes through on video, but this was just somehow just absolute horror to drive. And now it just feels like it should again. So it's nice. Some cargo here. Let's go for a rally ride. Right. And yeah, I think it might make sense to put a little bit more spring strength in those rear wheels. You can see that the compression, the spring compression is, or the springs are compressed, shall we say, quite a lot. So let's up that, maybe not to 40,000. Let's start with 35,000 and see what happens. Yeah, it's not a whole lot of change. Okay, so we'll do 40 again then. What was the truck number 2? Truck number 2 had 30,000, okay. Yeah, it's super slidey. Like in a way, hey Poseidon, or hey again. In a way, it's sort of tempting to move the center of mass a bit to the front, but I don't wanna do that necessarily. We could try moving it just ever so slightly, See what happens. Like 0.3 maybe. Super slidey still. You have to kind of drive this like you would a real truck, and not like a race car when you actually have cargo in the back. At least like this amount of cargo. Yeah, otherwise you're gonna end up like that. I wonder how much does one of those crates weigh? Dynamic props. Crate number 2. 350. Ooh, okay. So they're actually pretty... Yeah, these things are actually pretty heavy. 500 and 1,000. Right, so we're talking about some pretty heavy cargo here. That's interesting. is definitely drivable though, and the front, the gripper arm isn't really as big of an issue as I thought originally. Thought it was going to be a bigger problem with this, but no, we have other problems. But at least this ain't one, as the song says. 99 problems, but the gripper arm ain't one. Let's deposit some of these here, maybe a couple. See how that changes the drivability. The nice thing is that you can actually kind of easily let just a couple of these go. Let's go like whoop, and another one. Oh, no, I'm gonna have to be careful with this. Yeah, just that one and no more. There we go. So at least that part of this whole bed thing works really well. Yeah, it's already more drivable, but there's a little bit of driving on just one side of the of the wheels, like this kind of thing. Oh my god! Oh no! What? Oh, what? Well, that wasn't maybe what I had in mind. Let's see if we can get unstuck here with the unstuckifier. What's the goal of the game? The goal of the game is there are a few goals. There are a few goals of the game. One goal of this game, or this game project, if you will, is to create a fun sort of sandbox, physics sandbox with vehicles, a moddable sandbox with tools and vehicles that I can play around with and mess around in, but also people who want to do things themselves can mess around in. And that goes, that sort of includes everything from just playing the game and messing around with it that way to you know, creating levels for it, to actually writing mods for it in Zig and making content for it that way. That's one goal of the game. But there is going to be a single player campaign, and the single player campaign is sort of like a sci-fi road trip. So you basically need to travel through a sci-fi world. There's not going to be any fighting in the campaign. It's more of a puzzle exploration sort of deal. And actually this level is part of the campaign. That's all I'm gonna say on what happens in this level. You get to experience it yourself. But this level is part of it. Yeah, I wonder if this car should just simply be slower. I can modify that here, because like this is kind of ridiculous. Let's make it like top speed 60 maybe. Max engine torque we can maybe even bring up a little bit, and then max engine rotation speed a bit slower. Yeah, this feels better. We basically took a fourth of the speed away. This is still a little slidey, but this is more manageable, I would say. Does it have soft body physics? It has kind of has soft body physics, doesn't it? It has like antennas and things that bounce around. Death Stranding with trucks, yes. Yes. Indeed. But without all the flying whales and eating some sort of grubs and a baby on your stomach. The Kojima stuff. Soft body physics, it actually probably has a few different kinds of soft body physics, but like just a Scout, this has an antenna which kind of wiggles and sways depending on how you drive. I don't know if this counts as soft body physics. It might, I guess. Bonk. Yeah, I don't know if you've seen this, but this is actually a mod that I made, which you will get the source code to when I launch the version of the game which has modding support, which is most likely going to be the next release, pre-alpha 2. You can see I'm gonna fall off the world now. Whoa! It's basically just it's a Scout that has a jetpack on the back. Yes, I am using PhysX. Indeed, I'm using PhysX for the physics in this game. Yeah, this jetpack thing is just it's a mod that you can download, and you can mess around with the code for it. You can create your own mods. This is sort of like an example mod, something that you can do with the modding system. And the thing is super difficult to fly. So this is one sort of goal of this game, is just to create crazy things like this and mess around with them. When it comes to physics, Decima almost doesn't have any. Well, isn't Decima the engine that uses Jolt? It wasn't Jolt built originally for Decima? So I kind of don't understand what you mean by Decima doesn't have any physics. Whether or not a game like Horizon or Horizon 2 uses a lot of dynamic objects is one thing. That doesn't mean that the engine wouldn't support physics. Soft landing. Which rendering API are you using? This is D3D11. Currently, we can also run it in D3D12 mode. We just need to. I need to remember that. I think it's GFX API D3D12. Yep, now it's D3D12. There's some things that don't currently work with D3D12 that I need to fix before it can be fully targeted, but it kind of works. Or it does work. There's just some things that are buggy. Brrr, bonk. It just flies like a balloon that you let the air out of. Whee! So yeah, D3D12 should work pretty well. Just some things like resizing the window, I think, kind of breaks it. Not because resizing the window wouldn't work, but just because we do certain things, we resize certain buffers when we resize the window, and then kind of breaks it. Stuff like that. Yeah, you need to be kind of careful when you're driving this with these big things in the back. Which makes perfect sense, I guess. Can we get that thing to settle down there? Settle down, y'all. Yes, I'm using NVRHI, yeah. To say that backend doesn't matter isn't true, though. That's not really how it works. If backend didn't matter, then I wouldn't have these issues with D312, and I would also have Vulkan running already. See you later. Thanks for stopping by. But yeah, backend actually matters quite a lot, especially with NVRHI that doesn't do any sort of shader mangling or anything like that. From a programming perspective, it does matter. It does matter. Yeah, you shouldn't believe that you just enable NVRHI and then things just work. That's not how it is. That is not how it is. Take it from someone who spent 3-4 weeks working with this. I actually just the other day I enabled support in D3D12 for DXIL shaders, so I can run it in D3D12 now with both DXPC and DXIL shaders. And surprise, surprise, there were some new issues that came up with that. So it's not that you don't have to do anything. You just select your backend and off you go. That's not how it works. Add to that the fact that you're managing your whole loop yourself with the raw graphics API. So you need to write what NVRHI calls the device manager. You have to write it yourself. And so there are many different ways to do that. Well, not many, but there are different ways to do that. So there are definitely differences. But once you get those things sorted out, you can generally sort of work the same. But I, for example, now that we're running in D3D12, let's see if this now happens. I could resize it once. I could resize it twice. I could resize it 4 times, 5 times. We don't have enough objects in this level to easily reproduce this bug that I'm talking about. There we go. D3D12 device error. Failed to grow a descriptor heap. Well, as you may or may not know, there are no descriptor heaps in D3D11. And so this is basically has to do with how I manage my samplers. And I manage my samplers in a way that like D3D11 is completely fine with. D3D12 is not fine with that. Or D3D12 is not fine with what NVRHI does when I do my samplings the way I do. So there are all kinds of like small little details you have to keep in mind. What's the issue with Vulkan? There's no issue with Vulkan. I just haven't written a device manager for it yet. It should actually not be super tricky to get it working. I have all my shaders already compiling to SPIR-V. And so for a bit of context, I've actually had 2 separate Vulkan backends for this engine that I've written before. One was just raw Vulkan and another one was VEZ. And so from that I've done a lot of work on getting the shaders up and running. I'm not super interested in targeting Vulkan currently, because D3D12 works so well on Linux these days with Proton that I'm kind of just like not in a hurry to support that, but it should be, famous last words, it should be like a matter of writing a device manager, fixing up a few things like HBAO, for example, and it should work. But yeah, like I said, famous last words. Okay, guys, let's turn our attention now to the thing that we were actually supposed to do tonight. Which is do the gripper. Before we do that, let me just have a quick look here. No, gripper truck is what I want. Diff it. So what did we do? We moved the center of mass. I don't know if that makes any sense. We're moving it forward a little bit, but we're moving it so little that it doesn't really matter. I don't know. Well, I think we'll keep it like this anyway. Engine max rotation speed a bit lower. Engine max torque a bit higher. Wheelbase is now set to what it actually is. Yeah, that was a bit weird that I had it to 0.6. Wonder why. So truck has it. Truck number 2 specifically has it at 0.578. This has even larger wheels. And now the Creeper truck has a 0.578 as well. What does Scout have? Scout has 0.6. Wow, so Scout has actually larger wheels than the truck. That's a bit surprising, but okay. should make them 0.6. Not sure. I'm gonna try. What is actually the... What is the diameter of this guy? That's a good question. Cylinder. $90. If we make the radius 0.6, then where are we? Right, so the radius is actually a little bit larger even now. If we make it 0.65, 0.65 is pretty good. Yeah, I think 0.65 is what we'll actually want. And then we'll add 0.65 here. There we go. Yeah, remains to be seen if we actually keep them this large or not, but kind of don't think it makes any sense to have wheels smaller than the Scout for a truck. That's crazy. That is crazy. Crazy talk. Okay, pretty good. Now then, let's have a look at the gripper arm component. So this is the old one. So what do we need to do here? We need to get those so-called fingers working, and we have some meshes that we can use. I don't really like the design of that, but I guess we can live with it for now. I'm gonna hide that one. So this sort of thing, it sort of forms this almost like cylindrical kind of grip on something. And yeah, it kind of works. But I think I wanna redesign this to look nicer. But I think we're gonna go with this now. We still already have this centerpiece here. We just need these two to kind of grip the thing. So that would be that. They are probably, or I say they, I mean I've written this code, but this thing is probably using the same sort of propagated value business to set how much of that grip should be had at any point, or not. Vertical arm angle, fingers angle. Is that what it is? Right finger rotation, left finger rotation. So this is an update. I'm trying to move the visuals around. Okay. Yeah, and here we are. Okay, we're just reading the input state. We're not dealing with any propagated value things. So we're just reading the input state. We're getting the finger's angle, rotation speed, and then we clamp it, and then well, that is actually a propagated value, finger's angle. So we're just updating it here essentially. That's fine. That's when we open the fingers. When we close the fingers, we do the opposite thing essentially. Okay. And then we check in pre-tick if we have ticked the physics. At least one. Calculate the rotation of the counterweight around its x-axis. Well, we don't have any of that. But here, okay, here we set the drive goal pose. So this is the stuff that we do in the articulation graph these days. So AG dot, let's see, apply steering values. I think that's where it actually comes from. This is where we do update joint drive goal pose. Yep. Wonder if we should do that actually in pre-tick as well. Just like we do there. That might actually be a pretty good idea. Let's see if we test it out with the truck bed component. Drive goal pose. If we take that away, we create one of these guys. So truck bed. Now if I lift this up, the physics shouldn't move, and indeed they don't. They just stay there. Blah, 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 blah. Right. So we'll take this guy and we move it to pre-tick, which is, you know, typically where one would update the physics, so that then in tick, where the physics is actually calculated, you have up-to-date stuff. So I think it makes sense to actually move it here. It's more sort of more like the correct place. Might not actually be that big of a deal if we do it elsewhere. Except like, okay, one thing actually. Is this a good idea or not? Now we're doing this and it seems to be working fine. The thing with this though is that now we're running it every single pre-tick, and that's maybe a bit unnecessarily heavy. Since here we're doing it only when we are applying the steering values. And that happens only when the steering values actually change. Yeah, maybe we'll actually keep it like this. I'll change my mind. Let's keep it like that. And so we do the same thing here. Let's go back to the gripper arm component and keep looking at this thing. Okay, so they're doing the set drive goal pose in pre-tick, and then they calculate the counterweight, which we don't have. And then at some point, On-gripped object name hash changed. Right. So it keeps track of the object that it has gripped. And it stores that in a propagated value. So gripped object name hash. It's a string hash of the object that it has gripped. Okay, cool. And yeah, the reason why it does this is that you can insert objects into like receptacles. And if you do that, if you take like lift something and then you insert it into something else, then we basically need to tell this gripper arm that, hey, we don't have that anymore. So whenever a dynamic object is inserted, it checks like, okay, is the name hash the object that I was actually holding myself, and then it sets it to 0. Okay, so that's good. Let's add this to a list of things that we need to actually deal with here. Add it here to the beginning. Let's just do to do some notes for myself here. So that one, we also need the grip joint. That's something that we need, which we will look into just a second. Let's activate like Zen mode here to Zen mode. Get a bit more screen estate, screen space. Where's the? There we go. Gripper arm component. Here we go. All right. So that's mesh data, mesh data, mesh data, mesh data. Yeah, we need a finger mesh data. Actually, we have it already. Yeah, we have it already. We're never filling it in. That's fine. So grip object. This is called. This is called when. Actually, where is this called? Right, this is called on every pre-tick. If we are closing the fingers, the grip is tightening. See if we should get a grip around an object. Yes. So then that checks if now would be a good time to determine that we are gripping this. Let's do it like this. So we want a function like that. Might want an in pre-tick. And if we do, then we send a message that, hey, we have now gripped an object. Which object is gripped is then added here to the params. So that's cool. So send dynamic object gripped and receive dynamic object inserted, right? Those are the two interesting things. They're both found in dynamic objects. Here, gripped and inserted, yes, okay. That's neat. So grip object checks the force that's exerted on the joints, left finger physics joint and right finger physics joint. And if they exceed some thresholds, so lower threshold, if the left finger force is higher than that, and right is also higher than that. And then a higher threshold, either one of So this is like and. Both of them need to be higher than the lower threshold. One of them need to be higher than the higher threshold. Then we actually determine that yes, we are now gripping this object. I think that was to like filter out some crap. I did it like that. And then create grip joint. Where is this called? Right, it is called on gripped object name hash changed, which gets called automatically when we set the name hash of the object that we're gripping. Cool. So that one. There's grip joint. Great fixed joint. Yes. Yes. Yeah, projection is something that we don't support anymore. Physics 5 doesn't support projection, so that doesn't really mean anything. We specify the hit point in each other's local spaces to fix them to each other. Using the inverse as the object orientations, make the joints take the current relative rotation into account, fixing them without rotating them further. Yeah, so it kind of just like welds them together. All right. And then we're just basically building the arm here. Create vertical arm, create horizontal arm. We don't need to do any of this because we have the new articulation graph, which just handles this and does it better, quite frankly. But what might be kind of interesting is to take a look here at the physics of that gripper thing. So it looks like this, and we need to somehow specify these collision shapes for the new one as well. It says here that the gripper seems to behave a bit nicer if the two innermost segments are left out. So basically, it's talking about like not having any collision shapes here. So both of those green fingers there are their own actor, and then you kind of rotate it like this, and the fingers rotate with it. And I know this is very confusing when we have both of these on. Let's disable those. So we're looking at specifically the red ones, or the magenta ones. They are the physics bodies. So we need to make that, add those as part of adding the fingers to the actual hand. And it's kind of jerking it forward and backward a little bit. Yeah, this is a strange vehicle. Very strange. Strange little thing. Yeah. Okay, that looks cool. I think we can basically start by adding the meshes to the object, and then setting up those probably those collision shapes there. That should get us started. And then we can make it so that you can actually open and close the fingers. And that should be pretty good. So let's go with that. I think I'm going to create a new mesh here for... How do I want to do this? Let's just move this to the center, I think, and we're gonna... So gripper arm finger. Yeah, and I think I actually want like 2 of these, because I actually want to be able to make them so that they're not actually quite symmetrical. So let's do cursor to selected, and then we go here and we flip the X. And then duplicate this guy and move it to cursor to... No, not cursor to selected, damn. That's not what I wanted to do. Selection to cursor is what I wanted, and then we do pivot point as 3D cursor, and we rotate around Y 180, and that gives us the other part. So gripper arm finger left, gripper arm finger right, and I'll call it fingers actually. And of course I got it the wrong way around. Left, right, there we go, right and left. So now then, now we can just move that there, export it as that, basically. All right. That looks good, and we can actually store this place here. This is the right one, yeah. So just manually convert that position to game engine coordinates. And so that would be, that's X. And its sign is flipped. And then this would be, that would be the Y, and the Z is this, and again the sign is flipped. Yeah, that looks good. So now then, now we can do, let's have a look here. Where's the arm mesh? Probably right above this. Gripper arm mesh is right there, yeah. Okay. So what we'll do here is add another one of those. So mesh. Dynamic, no mesh blocking. And we can get the left, is that left or? We can start with the right. Let's start with the left. Kind of makes more sense. Left to right. Yeah. Okay. Yeah, that didn't like. Okay, let's exit out. I'm gonna fix this up. So gripper arm, gripper fingers. Yes. Gripper arm fingers. Left. That's the left one. Block out. Dark gray maybe. Yep, and then we'll take that coordinate that we had, and now we need to negate the X one because we're on the left side. Okay. No parent component. No parent component here either. Then we do the right side. That's the arm. Where is it? Where is it? Truck arm. There we go. Let's use the same dark gray material and we do the right. So mesh right, it's dynamic, doesn't block the nav mesh. And this one needs to be moved before the gripper truck arm component. So now we can actually input this. Left fingers mesh is gripper arm fingers left, right fingers mesh is gripper arm fingers right. And now we should be able to turn back on this one. And we can see that what is this? That doesn't look correct. What is going on? Did I actually export these guys? With some scale or something? Nope, location is that. That should be fine. So what's actually like if we just make that 0, 0, 0? Oh, now it works. So did I actually export these incorrectly then? That should be exported at the world origin. This would be the right one, and that would be the left one. Yeah, okay, evidently I did. That's an easy fix. Position, just take that minus out, and now we have them in the correct place. Okay, so that's good. Now then, we need to take this and input it. Right, left finger's fixture position is that. Right finger is the one without the minus. Here we go. And so now I think actually if we play the game, get rid of that for the time being. Oh, I should make it load that truck test level. So gripper arm. Ah, yeah. That is something that we need to fix, but it's kind of easy. Isn't there lateral friction with the wheels to prevent slipping? Kind of depends on what you mean by that. Like physics tracks both lateral and longitudinal slipping per wheel, and I track it too. I use it to drive particle systems and that kind of stuff. Depending on what you mean by isn't there, I mean that all depends on what material you're driving on, right? Materials specify the friction value. What is this? Expected type expression. Oh, it's that one. It's tripping me out. But if you're asking like whether or not we are tracking it, then yes, we are tracking both longitudinal and lateral slipping for all kinds of things. That's what failed. What? Right, the joint is not created yet. That makes perfect sense. Yeah, I guess we need to create those before we can actually use this code. But let's quickly have a look here at. This gets a little hairy. Part is self.ag.physicsparts node.idx and if part.joint is not null. We can do it like this. I just want to make sure that actually updating the mesh. Updating the mesh now works, that it follows the arm movements. Not doing that though. What am I forgetting here? You have both forward and sideways friction. Yes. Yeah, so if you look at like it's not that. Is it physics.zig maybe? Vehicles. Yeah, alright, so here we go. Vehicle wheel state info. This is a struct that you can request from a vehicle controller, and it has longitudinal slip, lateral slip, tire friction, suspension jounce, suspension spring force, surface material, C++ pointer if you want to get the actual material from that. In the air, steering angle, rotation speed, contact point, you get all kinds of information from the engine about what is happening there. So yes, like forward is typically forward-backward friction is what you call longitudinal, and then sideways friction. So like cornering and stuff like that. That is typically called lateral friction. Mesh datas. Let's have a look here and see. Yeah. Self-mesh data. I'm thinking that this might actually be the problem here. Left fingers and right fingers. So what happens if we do this? Put a breakpoint there. Okay, so data. Yeah, we have those. That's good. We have those. Are we actually setting the hatch meshes as children of the bed here? No, we're not doing that. And yet they rotate along with the mesh. Yeah. Alright. So why do the fingers not rotate along with the arm? That's what I want to know. Left finger's mesh component name. Gripper arm fingers left. Yeah, it's right there. It's probably something really stupid again. Yeah, this is kind of curious. I bet it's something really stupid, but I don't see what it would be. Actuator mesh, windshield mesh. Where the truck bed? That should really be called truck bed mesh. Oh, well, it's a truck bed component. That's why. Yeah, okay. They are actually parents of the bed mesh. I've just been reading this wrong. That makes perfect sense. That makes absolutely perfect sense. So gripper arm fingers left. Mesh. Actually. Like that. Gripper arm mesh. So these need to be children of gripper arm mesh. Right? Yeah, that is the correct setup here. All right, that should be better now. Yeah, now we need to actually cancel out that position probably, right? So if we go and have a look at the meshes, right hatch mesh. No, what? Oh. Yes, okay. Yeah, so these... Oh, this is annoyingly complicated still, even though I made it less complicated than it is. But these... these positions for these fingers, they need to be given in essentially this arms coordinate space, right? So if we do what is it? Active element maybe. Actually, we need to do it like that. And then we rotate it here. Yeah. So they need to be nested under the arm. And the position needs to be given in reference to this arm, not the world position, which also makes perfect sense. Right. It's just that the collision shapes need to be given in the space of the entire vehicle, which is a little maybe complicated, but okay, let's try to deal with this. Yeah, you can see these lines going here to that. Okay. So how do we make that happen? Well, we can maybe move these things. Let's see, if I take that one, and that one, and we isolate them like so. And then we make that the active one. And then move it here, right? So now we get a new coordinate that we can use. Yeah, I apologize for the mix-up here. I'm clearly starting to lose some of my brain power for today. That is to be expected, I guess. So what we want now is, let's have a look. That would be, what is that? That's positive z. So something and positive z, and the something is this but negative. Isn't that how it works? I don't understand what this location is here in Blender. This is super confusing. I was thinking, like, if I'm in object mode and I have my pivot here, you can see the pivot and the 3D cursor being in the same position, right? I can rotate around and you can see that, okay, they're in the same position. If I select this object, I expect this location here to be, you know, this thing. Evidently it's not. Because if I go and look in view, it's like minus 0.5, 4.7, 0.3. But then in view, the location is like 0.5, minus 2.38, 1. And this makes sense. This I can actually sort of, by eye, I can see that, yeah, that is the correct. That's the coordinates I want. I don't know what these are. I don't have any scale. I don't have any rotation. So like what? Is it just that these are somehow like since they're nested underneath that? Yeah, I think that is probably what it is. It's because they're nested underneath the object. Or something. Pivot relative to world. Yeah, but exactly. But like if you make let's do it like this. So we create a new object here. Actually, first we copy these. That was just crap. I don't know what that is. And these are the coordinates now for the object, right? minus 53, 0.53, 4.7, 0.37, okay? No, I don't want it to be relative to the parent. I just want it to be in world space. But now if we input these guys here, where do we end up? We end up over here. Yep, there we go. And now we can scale. I'll scale it down like median point. Brip. That's where we end up. That's not at all where we want to be. Right? This object was probably originally there, but now it's not. Instead, what I want is this position here now in world space, right? So I can go cursor to selected, and it jumps here. Doesn't jump here, even though this thing has, you know, I can toggle between these two objects now, and you can see like nothing changes here in the location. So they're in the same coordinates, like from this. And what I want is this position where the 3D cursor is. Anyway, it has to do with the nesting. I'm almost certain of that. But I'm just gonna have to use this one instead. So that would be flipped X, and this would be flipped Z, and this would be flipped Y. No, actually that is just non-flipped Y. Yeah. Yes, that's non-flipped Y. These are the coordinates I want for my finger meshes. Ugh. That was a load of crap. Let's undo all of this. So let's input this. We need to give it, let's see. So not right hatch mesh, but right fingers. Gripper arm fingers left. Is that with a minus in front of it? And the right one is without a minus in front of it. Isn't that what we want? It may or may not be. Let's see. Yeah, now it's looking better. Yay, and they're moving and everything. Okay. Oh, that was way too much work. In fact, it wasn't. I mean, I was just being bad. Yeah, the parenting in Blender tripped me up. I haven't done like a whole lot of it. I usually work sort of in world space in Blender, but yeah, it can be a little bit weird. Okay, so now we have this thing, and we should have the physics objects still for the gripper arm. Of course we don't have it for the fingers because we haven't specified that, but now we should finally be able to specify those as well. So the way we do that is we need to uncomment a few lines here. Oh, actually I already did. No, that's the wrong one. It's this one. Here we have the uncommented stuff. So take those back. Left fingers collision shapes, right fingers collision shapes. Yep, that looks good. So, if we build this, And we go here. So we have some weird looking boxes here under the vehicle. Those are the collision shapes that we haven't really been able to fill in yet. So it's basically this thing here. But I want to make a couple of them here on this side and a couple on the other side. So let's get, yeah, that's the left one. Just move this forward probably. 3. Then we can see it appearing. Here it is. A little bit more. Something like that. And I'm gonna bring it up. So position maybe 0.5. That's a bit much. 0.4. 4 is pretty good. And size is going to be probably like 0.3. Height is pretty good. 0.1. What about that? I think that looks pretty alright. And then we need to move it over to the side. 0.5. Actually, this is the left finger, so we'll go with minus 0.5, but let's do more. 0.7, 1.2. Now we're approaching this. Starting to look pretty good. A bit forward still, a bit more to the side. Something like that, and then let's rotate around Y, like 30. A bit more, 40, 50, 55. Yeah. Something like that, maybe. Yeah, I think that's probably good. We'll add another one. Same size. We'll start with the same position. Let's do the rotation. Less rotation. Then we start lowering this as well. 20 maybe. No. 10. I don't know. Maybe. Something like that. I think I want even less rotation here, actually. Yeah, that looks pretty good. I think, in fact, that this is probably also too much. Something like that, I think, is pretty good starting point. So then we take these guys, quite simply copy them to the other side. We just need to flip some signs. So the angles will be flipped and the x-axis will be flipped. There we go. Now we have those. All done. Okay. So now then, I should be able to take out that one check that I had here. Sort of a hack. Like that. And now, hopefully this will actually give us the fingers, the physical fingers. It sounds like a, I don't know, the butt of a bad joke. Gripper arm. We can see that we actually do have them there. Neat. There's something funky going on with the they're shaking like a whole lot. Do I need to like linear and angular might be required for this. Let's see. Yeah, there's a whole lot of shaking there involved with that. What's that about? There shouldn't need to be. Is it actually only the... It's kind of only the clients that are shaking, is it? It looks like it is. Strange. Yeah, there's no shaking involved in this. So why would they be in this? Well, might just be that it's like so much faster than the bed. Where's the movement? Movement. Here, arm rotation speed. Let's lower that significantly. I'm gonna change the startup level here to be the truck bed work level, which is easier to work with. Already has the correct vehicle and everything. So yeah, it does help with the shaking, but there's still a little bit of it there for some reason. Probably needs to be tweaked somehow. I'm thinking. Yeah, there's basically no shaking here on the server side at all. So I don't see why there would have to be anything like that on the client side either. Yeah, you can see this from these mass frames here that they're kind of wobbly. Then we switch to the server one, and they're just much smoother for some reason. That's strange. What's that about then? Other than that, it looks to be completely correct. So that's at least something. Set to like 0.1 maybe. Okay, so the fingers then. Opening and closing the fingers. I think that should actually already work, shouldn't it? Alright, here we have something funky going on with the transform. So that's not good. Yeah, they're sort of flying away a little bit. Yeah, we can get rid of this last collision object there in the arm, at least. That was there just to sort of emulate these fingers before we had them in place. Oh, what did I do? That's the main one. 1, 2, 3, 4. Yeah, that's we want to take that away, like so. Yeah. Now it's gone. Good. Yeah, it's rotating around something else. What is it rotating around actually? Left finger's fixture position, right finger's fixture position. It is possible that I didn't actually set those. Let's see. I'm gonna look at this in the text editor here. It's just easier. Vehicle blueprints. Let's see. Right hatch mesh. It has that mesh position. So is the same thing set here? Yes, it is. Okay. So now we can look for fingers left mesh. Yeah, okay, we have the mesh positions incorrectly set. Right. Blah, 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 blah. Gripper truck arm. Yeah, here. So left finger's fixture position should be that. And that. Right, so now, there we go. Look at that. There's no jittering anymore, and it's just working exactly how we want it to. Okay, good. We need to allow for some more closing though. This is like the maximum close angle that we have currently. So that's not good. What do we have? X fingers open degrees. Let's see here. So when fingers open is 0 is then it's fully open, and with 1 it's fully closed. Yep, that makes sense. So in the beginning it's fully open, right? Yep. That makes sense. Apply steering values. If we open the fingers, I think this might be the wrong way. First of all, if we add a gripper here, do gripper arm, this closes and this opens. X closes and B opens. Okay. X closes and B opens. Yeah, we need to give more speed to this closing and opening. Right. Okay. Max fingers closed degree is what this should be called. And let's make it like 120 maybe. Speed is right there. Okay. Make that faster again now that we have that jittering sorted out. So gripper arm, close, boink. Yeah, so 120 is a bit too much. 110 maybe. Okay. Yeah, that's nice. All right, so, you know, in an ideal world, we would now be able to lift things and plonk them into the back. And we can try that. I don't think it's necessarily going to work, but we'll see. So let's do a power cell. Let's rise nice and round. And turn those things off. So now if we want to pick that thing up and put it in the back, what we do is we drive close to it. First of all, we should be able to poke at it with these things. Burp, burp, and we can. How cool is that? Just drive here, like that. And then gripper arm and close it around that thing. And it's like, it's jittering a little bit, like, what are you doing to me? And, well, it is actually working. Hey! It is a bit wonky though. So let's put some stuff here. Let's see what we can actually pick up with this thing. That's gonna be an issue, but let's try. A large box, one of those smaller boxes. All right, let's see what we can actually do with this. If we approach this large box from this side, might be able to pick it up. We might. Like this, and then a little bit forward. And then, like, you shouldn't squeeze them too much, because yeah, it does work. Hey, look at that. It's very jittery though, because we're just like penetrating it there with our rigid bodies. That sounded dirty, but it is in fact what we did. So this actually does work, but it doesn't feel very nice. It feels just janky and hacky. And to achieve that nice sort of chunky feel, we need to get that that grip joint working. Also, the collisions for that centerpiece is not really what it should be. But you can actually already use this pretty well. And that's That's encouraging. Right, and now if we have too much stuff here in the front of it, we can just tilt it a bit and have them hopefully fall to the back, like so. How cool is that? Oh, let's not open that. No, no. It's pretty fun though. Now we have a small box. We need to really use this feature that we added, which allows us to really sort of point that at the ground. Yeah, we can't actually really grab this now. Might be able to do it if we do it very carefully here at the front. Yeah, can't really do that. That thing is too small to pick up with this thing. You can move it around like this, if that counts. But yeah, okay. That joint should help with that as well, because we can detect that okay, there's pressure on the on those fingers, and we cannot just magically lock it into place. That also works. Yeah. Yeah, this kind of works. It's not really all that fun to mess around with until we have that joint working there. But I think I've reached pretty much the limit of what I can do in one day. I've been streaming for what was it? What was the previous stream? Probably. Yeah, almost 5 hours, and this is a little bit over 2 hours, so that would be 7 hours today. Pretty solid work actually. So yeah, I think we're pretty good. I think we're pretty good. Good day's work. Yeah, you can see because they'll sort of get stuck with this, but now it's for different reasons. For this, the integral, not the integral, the what's it called? Differential is what I'm. Different mathematical terms. Differential is what I'm talking about. The differential would help with that. We have the torque vectoring. Might need to port that over from my Physics 4 fork to my to Physics 5 essentially. But we'll see. Might not be needed. Anyway, this has been a pretty good day. I think this is showing promise. There's some open sort of design questions with this vehicle that I need to kind of solve, and I probably need to put it in front of you people so that you can give your opinion. And that is, of course, one of the ideas with pre-alpha 2. You should be able to do that. But yeah, I think it's showing promise already. Today I will hopefully wrap this first version of all the functionality for this car, which means that we can then start to actually texture it. It should be fun, and then we can add all of the effects and sounds and everything to it. But I think I will be probably taking a break from streaming tomorrow. I've been doing it so much lately that I can't do it every day necessarily. So probably good to take a bit of a break. But here I have a to-do list for how to get that gripping working, and I should actually be able to then just use this instead of the old gripper for the demo mission, which you also get to play once pre-alpha 2 comes out. And I think it's gonna work well and be a lot more fun to use and drive around with than the old gripper, so that's pretty nice. Anyway, that's pretty much it for today, I'd say. If you want to play the game, then as always, you can join the Discord, where you can find a link to pre-alpha 1 and soon to pre-alpha 2. Unless I get it put on Steam, but we'll see. That remains to be seen. Pre-alpha 3 will be on Steam for sure, but pre-alpha 2 might still be a Discord exclusive. Regardless, do join the Discord server if you find these things interesting and fun. And remember to subscribe and do all the other YouTube jazz. You know what to do. Thanks to everyone who came to hang out today. And see you in perhaps a few days. Well, I'm not exactly sure. I might surprise you and do a stream tomorrow or the day after tomorrow, but I'm not sure. We'll see. We'll see how work goes. Anyway, have a good evening, folks. Take care.